All right, so for this one, first question is, all right, using the table, what's the probability a customer has 2 pets? All right, guys, use the numbers from the table. Some of you guys just see 2, and then you automatically think it's 2 out of something. No. Use the table. Read the table. Figure out how many customers have 2 pets here. All right, so let's start it off on the right note. Let's start it off. Come on now. You got it. Will, here we go. How many customers have 2 pets?
33.
33. And this is probability, so I need 33 out of. Will, you're going to quickly, if you can for me, add up the total number of customers.
Out of 100.
There you go. 33 out of 100. Basic way to use this table. There's 33 customers out of a total of 100 that have 2 pets. No issues. Anything from you guys? All right, let's move on then. What about part B? They have at least 3 pets. Now you guys got to remember what at least meant. All right, at least 3 pets. Anybody want to give me another, in their own words, what at least means to them? At least 3? Go ahead and chime in if you want to tell me what at least 3 means to you.
3 or more.
There we go, 3 or more. So I'm not just going to take one number here. I'm going to have to take a few of them. All right, at least means 3 or more. So just don't take one number, take a couple of them. So how many customers do I have that own 3 or more here? 9, here we go. Hunter, how many own 3 or more?
27.
There we go, 27 out of the 100 Will just gave us from the last problem. You guys want to ask any questions? This is a basic table right here before I introduce a more complex one. Any questions on using this basic table to solve those 2 probability questions? All right, let's go to a more complicated table then. I want to introduce you to what's called a two-way table. All right, this one right here is called a two-way table. Why is it called two-way? Because it's got 2 categories to it. You guys see it's got gender for one category here, and off to the side, it's got going to college or not going to college. So a two-way table is going to have 2 categories now. Not just number of pets like the last one had. This one's got gender on top, going to college or not on the side. So 2 different categories. All right, no, shouldn't be a big deal for us here. We got it. I know there's a lot of numbers in there, but look at letter A. Find the probability you pick a female and going to college. You pick a person who's female and going to college. So what I need to do is, using my two-way table, where do female and going to college meet? And that'll tell me how many people doing both. How many females and going to college? So where do they meet here? How many are doing both there? How many are doing both? Hunter, back to you again. How many are doing both? 13. And now I need an out of. You don't need to add up anything, guys, because you see I have a total column there. What's my total? Hunter, how many total people are in this? 52. All right, you don't need to add up anything here, guys, because I give you the total off to the right-hand corner. And if you guys do want to reduce that, you can to 1/4. Everyone okay on where Hunter got the 13 from? Female and going to college. All right, let's roll. Part B now. It looks like I'm asking the same exact question, but it's not. Probability, it would be a female or someone going to college. So I'm not asking female who's going to college. It's a female or someone going to college. Hey, what lights up my eyes? What lights up my eyes? Woo, hey, how you been? How you been there? How you been? Or, yep. So it knows I'm going to have to add up something. All right, let's go to the one side. Female. Chances you're a female in this group. Look at the table. I'm not talking about colleges or nothing. I'm just talking about female. How many in the table? Kian, how many females in the table?
22 over 52.
22 females out of 52 total people. Good. Female or going to college now. And I'm just talking going to college. Regardless of your gender, going to college. How many? Here we go, Colin. How many going to college?
29.
Yep. Out of?
52.
Got it. I'm going to stop here because we're not done. Anybody know a problem we're going to run into here? What happened that shouldn't, it's a big no-no for us. Big no-no.
You have to subtract the 13 thing.
Hey, guys, remember in problem in letter A, there was 13 females that were going to college? Well, I counted them here because they were female, and I also counted them here because they were going to college. I can't count them twice. So Caroline's right. I do need to subtract out those 13 that are doing both. Remember that in an OR problem. You have to subtract out the both. Everyone okay on why I'm subtracting it out? There's 13 people you counted twice because they were female and going to college. All right, you can use your calculator. Remember, the denominator stays the same when you add and subtract. Oh boy, what do I get there? That's 51. 38 out of 52. What? 19 out of, oh, okay, we got a reducer and stud on our hands here. I forgot. 19 out of 26. Yep. Are we okay on why I had to subtract out the OR? It's an OR problem. Add and possibly subtract. Remember that with an OR problem. Add, possibly subtract. All good. All right, that's our first exposure to a two-way table. Here's your second exposure to a two-way table. The old prom now. Live band DJ. Which one should we have? Males and females have their opinion. Before I start answering the questions, do you guys see something that's missing from this two-way table that I gave you in the last one?
A total.
Yeah, I would highly recommend before you answer questions, if your two-way table does not have a total, you put a total there. Because that just saves you so much time figuring out what it should be over. All these probabilities, what should be in the bottom. So why don't we do that? Why don't we make our own total column and row? So total. I'm just, again, is it required for me you to do that? Nope, not at all. I just think it goes a lot quicker if you know the totals for everything. So you don't have to keep punching it in your calculator. All right, so go ahead. Looks like total number of males. I'm getting 205. Total number of females, I'm getting 230. Total people who want live a band, 198. And the total number of people who want a DJ, 237. And it doesn't matter whether you add up the column or you add up the total row. You're still going to get 435 people here. Still 435 no matter where you add. All right, so I know most of my denominators here should be 435. Perfect. All right. Probability you select a student that wanted a DJ. So I'll give you guys time. Look at your table. A student wanted a DJ. What's the probability student wanted a DJ? Boom, 4. Nick, student wanted a DJ. What do you got for me?
237 out of 435.
There you go. I don't know about you guys, but doing the total columns ahead of time makes things a lot easier. 237 out of 435. Student wanted a DJ. Probability a student is both male and wanted a live band. Now I'm getting real specific here. Male and wanted a live band. So where should I go in my table for this one? You don't see the word or there, so no adding or subtracting. You don't see the word or. I want male and live band. Dan, here we go. Male and live band. How many of them are there?
103.
Out of?
Out of 435.
Okay. Everyone good on where that came from? We're moving. All right, let's slow it down because now they get a little tougher. You select a student that's female or wants a DJ. Oh, wait, hey. Female or wants a DJ. All right, let me start with the female part. How many females we have working here? 10. Caroline, how many females?
230.
230 out of 435. Plus, how many wanted? Oh, you're done. Settle down.
Okay, sorry.
Or want a DJ? Bassett, how many want a DJ? You might have been on mute there, Bassett. How many want a DJ? Can you hear me, Bassett? Okay. Maybe not. Get back. I mean, your mic, 237. Yeah, oh, the senior quote of the year, my mic isn't working. 237 out of 435. But you know what? You still got the job done, Bassett. That's what matters here. No excuses for you. Good. Now, hold on, though, guys. See, here's the thing. I know if I stop at this point in the problem, I did something wrong. Here's why I know I did something wrong. If you add up the two numerators, you're going to get 467 out of 435. You kidding me? Probabilities can't be bigger than 1. So you know you did something wrong or you just haven't finished something. We need to subtract out the ones we counted twice, which were females that want a DJ. So females that want a DJ, I still have to subtract 135 from this, the both. So even if you forgot to subtract the 135, you better not be leaving 467 over 435. You know better than that. And then we come up with, I had it here, 332 out of 435. So please, guys, watch out for the or. Make sure you subtract what's in common. All right, now I'm really going to take a different direction here, this last part. Have you noticed in parts A, B, and C, I've asked, what's the probability you select a random student? Now I just want to know a selected male. Now we're just going by the males now. Now we're just going by the males that want a DJ at prom. Just from the males, how many want a DJ at prom? 10. Caroline, how many males want a DJ at prom?
102 out of 205.
102. Yep. Here you go, everyone. 102. But you'll notice now it is not going to be out of 435 because I'm not picking from the students. I'm picking from what, Caroline?
The 205 males.
The 205 males. So it's out of 205 now. All right. Everyone see that? When you're selecting out of the whole students, yes, you take the whole total, 435. Go ahead. Oh, never mind. You're just patting yourself on the back again. Everyone good? Question on that one?
That wasn't me.
No? Questions? Relax. Everyone all right? Why it's 205? We got two more. All right. That's nice. But how about a two-way table where you have to fill in everything? All right, so here's a blank two-way table. Freshmen, sophomores on one side, attending, not attending on top. So I will let you guys go ahead and try to fill this table in on your own. based on the info I gave you above. You will have some blanks, but you have enough information to fill in those blanks. Okay, so just fill in what you can, and then using that info, go ahead and fill in your blanks. All right, let's check. Let's check if we have the correct numbers in here. It started off by saying 66 freshmen responded. So we had a 66 in the totals for freshmen, with 32 saying they would be able to attend. So 32 freshmen attending. 84 sophomores in the total. 46 said they would attend. And that's all I gave you. So from here, you should have been able to fill in the rest. So I got 34 freshmen not attending, 38 sophomores not attending. Total number of people of attending, 78. Not attending, 72, for a total of 150 people here, total. All right, help me parts A, B, and C. I'm not even going to call on anybody here. The only thing I want you to realize is the word probability does not come up in parts A, B, and C. So there is no fractions here. How many students responded? Total 150. No probability here, so no need for a fraction. How many are attending the dance? You guys wrote it in the total, 78. And then finally, how many of the surveyed sophomores are not attending the dance? Sophomores not attending, 38. There's no need to put it out of 150. I didn't ask for the probability. I just wanted to know the number. So please do not put it out of 150. Any issues there filling in your own table? Not bad at all there, right? Not bad. All right, one more and we're done. Male, female, A or not an A. There's your two-way table. You guys know what my suggestion is, right? Before we start answering this questions, put a 1 on here. Put a total on. Okay, put a total on your two-way table if one's not already provided for you.
Can you scroll back up to the other table for a sec?
These here?
Yeah.
What's wrong?
I don't know. I must have just spelled something wrong.
Did I? I don't know. I don't think I had. Did you get the 32, 46, 66, and 84 where they should have gone? From the beginning of the problem?
Yeah.
Okay. So to get the 34, I did 66 minus 32 to get to the 34.
I think I just didn't write 66. I think I did something else on X.
Well, do you see where I got it from the problem, and do you see why I put it where I put it in the table, Caroline?
Yeah.
Okay.
Yeah, I don't know where I did that.
Okay.
Other things.
All right. Yep. All right. So it looks like I got 6 and 13 here. I got 9 and 10 here for a total of 19. All right, and there's only one question here. What's the probability that a student is chosen from the class, so whole class, not males and females, whole class, that it's a male who does not have an A? All right, male who does not have an A. What's the probability you choose a male that does not have an A? Here we go. Let's finish this off strong here. Mason, male that doesn't have an A.
6 out of 19.
There we go. Game over. 6 males don't have an A out of 19 total students. Questions on why it's 6, why it's 19? Anything? All right, guys. Quiz is on Friday. This is you have all the topics now that'll be on the quiz. Day 1 through 7 here. And then tomorrow you have an assignment. Questions, comments, any concerns? All right, good work. I'll see you tomorrow for your assignment. Okay, good job today. I'll see you guys tomorrow.
Have a good one. Thank you.
See you later, guys.